Okay, picture this. Someone drops this huge, official-looking government document on your desk. It's just full of acronyms, subsections, the works. And your job? You've got to figure out how to prove a super-critical piece of software works, like, flawlessly. Sounds a little intimidating, right? Well, today, we're going to pull back the curtain on one of the most important blueprints in all of software testing. We're going to make it simple.
So this right here, this is the cover for a document called the Software Test Description, or STD for short. You can think of it as the ultimate recipe book for quality assurance. In this explainer, we're going to take a guided tour through this thing to really understand how it makes sure our most critical software is ready to go when failure is just not an option.
So here's our game plan. First, we'll cover the what and the why of this whole blueprint. Then, we'll get into the nitty-gritty of all the prep work you have to do before you can even think about running a test. After that, we'll hit the heart of the document, the test cases themselves. And finally, we'll uncover the real secret sauce, something called traceability, and see why all of this is so important for any high-stakes project. So what's the real mission here? What is the software test description trying to do? Well, its whole purpose is to create one single authoritative plan that lays out every single aspect of testing a piece of software. It's also that when the government, or really any big client, gets new software, they can be absolutely sure it does exactly what it's supposed to do.
Now, this official definition looks a little dense, I know, but it's actually pretty straightforward. Qualification testing, that's just a fancy way of saying, let's prove this software actually works. And that other mouthful, Computer Software Configuration Item, or CSCI, just think of it as whatever specific app or program you're putting under the microscope.
So here's the bottom line. This document is the master recipe. It forces everyone to write down exactly how they're going to prepare for a test, what the specific test cases are, and the precise step-by-step procedures to follow. And this isn't just for the developer's benefit. It's so the client, the acquirer, can look at the plan and say, yep, this looks right. This is a solid plan to prove the software works.
Okay, so how does a document like this build such a rock-solid plan? Well, like any good blueprint, it starts by laying the groundwork. It's all about making sure everybody involved knows the complete who, what, and why of the test before anything else happens. The very first sections are all about identification and giving an overview. You've got to state the exact system, the specific version and release number, who's sponsoring the project, who the developers are, even a list of all other related documents. And trust me, this isn't just busy work. It gets rid of any and all ambiguity. There can be no question about what is being tested or who is testing it.
All right, so once we all know what's being tested, it's time to get ready. And I'm not talking about a casual, hey, is everyone good to go kind of checklist. Oh no. This section is all about creating a test environment that is so precisely defined you could replicate it perfectly every single time without fail.
The standard actually breaks this prep work into two main pillars, hardware and software. For hardware, you have to list the exact items, the specific switch settings, you even have to provide cabling diagrams. For software, you identify the exact programs and even the physical thing they're stored on, like a disk or a tape. The level of detail here is absolutely extreme, and for a very, very good reason.
And here's the why. When you were dealing with mission-critical systems, for defense, aviation, even medicine, there is zero room for surprises. Every component, every setting, every single cable has to be accounted for. That's the only way you can ensure the test results are valid and totally trustworthy.
Okay, we've set the stage, we've done our prep. Now we get to the real core of the STD, the test descriptions themselves. This is where the plan shifts from what we're testing to exactly how we're going to test it. And you're about to see the level of detail is just extraordinary.
Before you can even kick off a single test case, you have to define what are called prerequisite conditions. This isn't about general readiness anymore. Nope. This is about the very specific state the system has to be in the split second before this one particular test begins.
And the standard gets unbelievably specific here. I mean, we're talking about setting individual software flags, presetting hardware conditions, and even conditioning a simulated environment. It's all about creating that perfect, repeatable starting line for every single test you're going to run.
So you've set your prerequisites, you've run the test, and boom, you have a result. The next obvious question is, did it pass? But in the world of Mil-Std 498, success is not a simple yes or no question. It's actually something you have to define with incredible precision before you even start the test.
And that is why the standard makes you define the criteria for evaluating results. You have to state ahead of time the acceptable range of accuracy, the minimum number of valid combinations, the maximum time a test is allowed to run, and even what would trigger a retest. In this world, success isn't a feeling, it's a number you defined ahead of time.
Now we get to the part that ties this whole thing together and gives it all of its power. I mean, all this intense preparation and detailed testing is basically meaningless unless you can connect it back to the original promises that were made about the software. And this connection has a name. It's called traceability. The standard is crystal clear about this. Section 5 right here. It explicitly demands traceability. Every single test case in this massive document has to be directly linked back to the specific requirement it's supposed to be checking.
This right here. This is the golden thread that runs through the entire project. It's the ultimate accountability tool. With traceability, a developer can't just wave their hand and say, yeah, we tested it. No, they can point to requirement 3.1.4 and say, we tested that requirement with test case 4.2.7, here are the exact steps we followed, and here are the objective results that prove it passed. It's just undeniable proof.
And the document doesn't mess around. It makes this totally explicit. It is not a suggestion, it is a hard requirement. This chain of evidence is what gives the client total confidence that the millions of dollars they just spent actually resulted in a product that does every single thing they paid for. So, after this whole tour through the software test description, let's zoom out for a second and just look at the big picture. Why does this super-structured, incredibly detailed document matter so much?
Well, the takeaways are pretty simple, but they're incredibly powerful. This document is a complete blueprint for quality. Its rigor makes sure every test is repeatable and reliable. Its objective criteria take all the guesswork out of it, and most importantly, its demand for traceability ensures that every promise made is a promise proven.
And that kind of leaves us with one final thought. While this standard was born out of the needs of these giant government and military projects, its principles, they're universal. So think about your own work for a second. Could defining success more clearly, preparing your test environments more rigorously, or creating that clear line of sight from a requirement straight to a test, could that improve the quality of what you build? It's definitely something worth thinking about.